right, so this is topic 11, part C, and this is where you're solving a system using what's called either addition or you can call it elimination. So some books you'll see the word addition, and in some books you'll see the word elimination. All right, and so you want to solve this by using the addition method or the elimination method. It could be using one of these two words. So I need for you to make sure though that as you're going through these that you're looking at these steps. So these are the steps for using either elimination or addition. So the first thing you're going to do is you're going to line up your x's and your y's. Then step 2 is you're going to look to see if one of the variables has opposite coefficients. And if it's yes, you're going to move to step 3. If it's no, which most likely it will be no, then you're going to multiply one or both equations by a constant, and it would be the least common multiple in order to make the coefficients of x or y terms opposites. So step 2, you need one of those variables to have coefficients that are opposites. Okay, so that way when you add them, one of the variables is eliminated. So once you get past step two, then the next step is to add the equations and one of the variables will be eliminated, and then you solve for the remaining variable. And then you substitute that into one of the other equations. And that's it. That's all you do. So let's look at an example. Okay? So let's go to number 1. So the idea, now listen carefully, the idea when using addition elimination is this. When you add the two equations together, you want it to where the either the x's are eliminated or the y's are eliminated. Okay? So when I add those, x plus 5x is 6x. So the x's are not eliminated. 4y plus 3y is 7y. So the y's are not eliminated, right? So that so step 2 says look to see if one of the variables has opposite coefficients. So in order for them to be eliminated, if this is a 5, this has to be a negative 5, right? And so that's the idea. So that way when you add them up, the x's go away. When you add them up, either or the y's go away. Not both, but one of them. And so we're going to do this two different ways. So I'm going to go ahead and use a separate sheet of paper because I'm not going to have enough room on this side. So I'm going to go ahead and rewrite this over just to show you two ways in which you can do this. So x plus 4y equal negative 1. 5x plus 3y equal 12. So the first thing I'm going to do is I'm going to ask myself, let's go ahead and eliminate the x's first. And here's why I want to do the x's first. Because of this. If I want to eliminate the x's, if I want the x's to be eliminated, the coefficients of the x's have to be opposites. So if I look at the coefficients of 1 and 5, so if I look at the coefficients of x's which are 1 and 5, so the least common multiple of 1 and 5 is what? 5. 5 is the smallest number, the least. 5 is the smallest number that 1 and 5 go into. Okay? If you want to eliminate the y's, you would say this. The least common multiple of 4 and 3 is, what's the smallest number that 4 and 3 go into? I'm hoping you said 12, right? Least common multiple of 4 and 3 is 12. 12 is the smallest number that 4 goes into and 3 goes into at the same time. All right? Now, let's suppose you want to eliminate the x's. Let's suppose you want to look at that first. And in fact, that's the easiest one to do. And you'll see why. Eliminate the x's. So to eliminate the x's, I need the coefficients of x's to be 5, one to be 5, and the other to be negative 5, because of the idea of opposites. Well, this is already a 5, right? So I just got to make this a negative 5. And so basically you're going to do this. You're going to leave the second equation alone. You're not going to touch the second equation at all because it already has a 5. You're going to multiply this equation by negative 5. What you do to one side, you do to the other. So basically you're going to say this. You're going to take x plus 4y equal negative 1. And you're going to multiply both sides by negative 5. Okay? You multiply both sides by negative 5. So that is this part here. So look to see if one of the variables has opposite coefficients. And in this case, you knew that none of them did. 1, 5, 4, 3. Those are not opposites. And so if no, you're going to multiply one or both equations by a least common multiple in order to make the coefficients of x and y's opposites, by a constant in order to make the coefficient of x or y opposites. So I want, so my least common multiple is 5. So in order to get a 5 here, 1 times 5 is 5, but I want it to be negative, so that way one's negative, one's positive. And so I'm going to distribute, and so now you get this. You get this system. Now all these are equivalent, so you get this system. Negative 5 times x is negative 5x. Don't forget to multiply everything by negative 5 now. Negative 5 times 4y is a negative 20y equal, and the negative 1 times negative 5 is a positive 5. Over here, I get 5x plus 3y equal 12. Now, so I'm done with step 2. So that's step 2. So step 2, I already did that. Now step 3 is to add the equations together to eliminate one of the variables. So now if I add, these are eliminated. So negative 20y plus 3y is a negative 17y equal, and then 5 plus 12 is 17. And see how easy this is now. So now we're going to solve the remaining variable. So my variable is y, so that's step 4. So now to get y by itself, I'm going to divide both sides by negative 17. And so I get y to be 17 divided by negative 17 is a negative 1. So I found my y coordinates. So far, my answer has y coordinate of negative 1. But now I got to find x, right? So to find x, you got to substitute the value you just found into one of the original equations to solve for the other variable, and then write your answer as an ordered pair. So go back to the original. Always easy to go back to the original now. Go back to the original, and wherever I see the variable y, I'm going to substitute negative 1. It does not matter which one you use. Does not matter. I'm going to just go ahead and use the first one. So to solve for x, you're going to use one of the equations. So x plus 4y equal negative 1. And in place of y, you're going to substitute negative 1 in place of y. So I get x plus 4 times negative 1 equals negative 1. X minus 4 times negative 1 is a negative 4 equals negative 1. Adding 4 to both sides, I get x to be 3. So there's your x coordinate. So there's your answer. So your ordered pair is 3, negative 1. And you can check it. Let's just check it real quick. Let's just make sure we did this correct. So let's check 3, negative 1. So remember, when solving a system, you're finding the ordered pair that makes both of those true at the same time. Okay? So I'm going to rewrite the system. We have x plus 4y equal negative 1, and 5x plus 3y equal 12. So let's do the first one, first equation. So x is 3, y is negative 1. So I get 3 plus 4 times negative 1, and I want to see if that's going to equal negative 1. Well, 3 minus 4 is equal to a negative 1, so that's fine. Now let's do the second equation. 5 times 3 plus 3 times negative 1 equals 12. I'm going to see if that's going to equal 12. That's the question. Well, 5 times 3 is 15. 3 times negative 1 is a negative 3, and that is equal to 12. So 3, negative 1 works. So I solved this system by eliminating the x's. Okay? So when I eliminate the x's, I found my y coordinate. Once I find my y coordinate, I substitute back into one of the other equations to solve for the other variable. And you're done. Someone else, though, right, could have wanted to eliminate the y. So let me show you what to do there. So suppose we're doing the same number 1. Suppose, though, so this was number 1, x plus 4y equal negative 1, 5x plus 3y equal 12. Suppose someone wanted to eliminate the x's instead. Let's say that was there. I'm sorry, the y's. Eliminate the y's instead. Well, the least common multiple of 4 and 3 is 12. That's the smallest number that 4 and 3 go into. So I need these two numbers right here, these two coefficients be 12. but I need one to be positive, one to be negative. So in this case, I've got to multiply both equations by a number. Whereas over here, I only had to do one because this was already a 5. Okay? So let's go and do the process. So I'm going to go ahead and rewrite this over. X plus 4y equal negative 1. 5x plus 3y equal 12. So it does not matter, by the way, it does not matter whether you make this negative or this negative. It does not matter. You decide. So what I'm going to do is this. So think about this now. So I need this to be 12 and this to be 12. So what do I need to multiply 4 by to get 12? That's the question. Well, 4 times 3, right? So I'm going to multiply this by 3 and this side by 3. What you do one side, do the other. I need this to be 12. What do I need to multiply 3 by to get 12? Well, I got to multiply that one by 4. Okay, just like that. But I got to make one of these negative. It does not matter. So let's make the 3 negative. So negative 3, negative 3. Okay, don't forget to make this negative now. If you do this negative, you got to do this negative. And now what you're going to see is this. Watch how simple. Distribute the negative 3. I get negative 3x. A negative 3 times 4y is a negative 12y equal a negative 1 times negative 3 is a positive 3, right? The next equation, 4 times 5x is 20x. 4 times 3y is 12y, positive 12y, equal, and then 12 times 4 is 48. Now you see those are opposites? Once you get those to be opposites, you're going to add, here's the idea of addition, you're going to add to eliminate. Here's the idea of elimination. So now I'm going to add these. So when I add these, negative 3x plus 20x is 17x, 12y, negative 12y is 0, and 48 plus 3 is 51. Getting x by itself and divide both sides by 17, I get my x coordinate to be 3. So far, my answer, my ordered pair, is going to have x coordinate 3, and all I have to do is find the y coordinate, right? Find the y coordinate. Well, to find the y coordinate, now I got to solve for y. So to solve for y, you go back to one of these equations. So let's use the first one. So x plus 4y equal negative 1. So in place of x, I'm going to substitute 3 this time. So I get 3 plus 4y equal negative 1. Subtract 3 from both sides. I get 4y equals negative 4. Divide both sides by 4. I get y to be negative 1. y to be negative 1. And so there's my y coordinate. And notice it did not matter whether I eliminate the x's. I get the same answer. I get the same ordered pair. Or I do the process by eliminating the y's, I get the same answer. Okay? The idea though is this. You got to, whatever approach you use, whether you eliminate the x's or you eliminate the y's, you have to be using the least common multiple. And you have to do it in such a way as to this step here, the coefficients are opposites, so that way you can eliminate when you add. And that's the process. That is all you do. It's not that difficult. So now let's look at number 2. Now that you have an idea, let's look at number 2. So I'm going to go ahead and do number 2 in another sheet of paper. So we have 21x minus 4y equals negative 30. And we have 7x plus 3y equal negative 23. Okay? Now, so there's my system. So I want to find out what ordered pair makes those two equations true at the same time. Obviously, you're not going to graph, because graphing that was more difficult. You're not going to use substitution because you would have to get one of the variables by itself, and you did not put fractions. So it is easier to use addition method here. Okay, so let's talk about this. So remember, at some point you have to add, right? So if I add them, nothing's going to be eliminated. 21x plus 7x is not 0. Negative 4y plus 3y is not 0. So I gotta find the least common multiple of either the x's or the y's. It does not matter. It does not matter. So let's think about this. If you want to eliminate the x's, what's the least common multiple of 21 and 7? Well, the least common multiple of 21 and 7, the smallest number that 21 and 7 go into is 21, right? 7 times 3 is 21. 21 times 1 is 21. If you want to eliminate the y's, the least common multiple of negative 4 and 3 is 12, right? 12. Negative 4 times 3 is 12. 3 times 4 is 12. I'm sorry. Um, Negative 4 times negative 3 is 12. And then 3 times 4 is 12. Okay? So you decide, though. You have to decide, well, which one do I want to do? It does not matter. It does not matter at all. Some students are going to say, well, I want to eliminate the y's because one's negative, one's positive. Some may say, well, it looks to me like eliminating the x's is easier because this is already a 21. And so I just have to deal with one equation. You see? So that's it's just a preference. It is just a preference that you choose. I am going to, for me, eliminating the x's would be more efficient because you would only be dealing with one equation to multiply by. So I want to show you how to do that. So let's go ahead and eliminate the x. So I'm going to go ahead and rewrite this over. So I got 21x minus 4y equals negative 30. 7x plus 3y equals negative 23. Okay? So remember, I'm eliminating the x's. So the least common multiple is 21. That's already a 21, right? So all I have to do is make this a 21. Well, 7 times what's 21? 3. So you're going to multiply by 3. But what you do to one side, you have to do the other, right? But here's the other thing you got to remember. Oh, but they have to be opposites. So if this is positive, this has to be what? Negative. So make that a negative 3 instead. But don't forget to do on this side also. And now, look what happens. Watch how simple this is. You get 21x minus 4y equals negative 30. And over here, if you distribute, remember that's a negative though. You don't see it. That's a negative 3 right here. Negative 3. So if I distribute, I get negative 3 times 7x is a negative 21x. Hence, you see when you add them, you get 0. They eliminated. Negative 3 times a positive 3y is a negative 9y equal, and then 23 times 3 is a, times negative 3 rather, is a positive 69. Now we can add, right? Because when I add, the x's are eliminated. A negative 4y and a negative 9y is a negative 13y equal, and then a negative 30 and a positive 69 is a positive 39. And then you see I only have one equation with one variable, so I divide both sides by negative 13, and I get my y coordinate to be 39 divided by negative 13 is a negative 3. So part of my answer, I know that my y coordinate is a negative 3. And all I got to do is solve for x. Now the next step is to solve for x, right? And all you do is go back to one of these equations, it does not matter which one, and wherever you see the y, you're going to substitute negative 3. So solve for x. So let's just go to the second one this time. So solve for x, I'm going to use the second equation. I'm going to use the second equation, which is 7x plus 3y equal negative 23. So in place of y, you're going to substitute negative 3. So I get 7x plus 3 times negative 3 equals negative 23. 7x, 3 times negative 3 is a negative 9 equals negative 23. Adding 9 to both sides, I get 7x equal, and then negative 23 and a positive 9 gives us 14, negative 14, right? Then divide both sides by 7. I found my x-coordinate. My x-coordinate is negative 2. So the ordered pair that works is negative 2, negative 3. Just make sure you put them correctly. X, Y. This is X, this is Y. And again, you can check. Let's just go and check this one just to kind of show you. So to check, because you could have made a mistake, right? You could have made a mistake. So you have time to check, so let's just check it. So let's just check negative 2, negative 3. Make sure you put it as an ordered pair. Make sure you put parentheses. So this is your X, this is your Y. So go back to the original system. So my original system was this, 21x minus 4y equals negative 30. 7x plus 3y equal negative 23. All right, so that was your original system. Remember, that was this. So so you're going to check each one of those equations though. You got to do each one of those equations. So the first one, 21 times x is negative 2, minus 4 times y is negative 3, and you want to see if that's going to equal negative 30. Well, 21 times negative 2 is a negative 42. A negative 4 times a negative 3 is a positive 12, and when you add them up, you do get a negative 30. Now let's do the next one. 7 times x is negative 2, plus 3 times y is negative 3, and you want to see if that's going to equal a negative 23. Well, 7 times negative 2 is a negative 14. 3 times a negative 3 is a negative 9, and a negative 14 and a negative 9 is equal to a negative 23. Okay? So that was number 2. So you're done with number 2. Now let's look at number 3. So let's look at number 3. So in number 3, we have this one. Number 3. All right, so let's look at that. Number 3. So you got to determine, right? You got to determine, you want to do this by elimination addition. You have to determine whether you want to eliminate the x's or the y's. Okay? So let me go ahead and write this over. So this is number 3. So you have 4x minus 5y equals 23, and then 5x plus 2y equal 4. So remember, you got to look at the least common multiple. So the least common multiple of 4 and 5 is 20, right? And the least common multiple of negative 5 and 2 is 10. Okay? And so you decide, do I want to eliminate the x's or the y's? Do you see, though, that it doesn't matter which one you use because you're going to have to multiply both equations this time. Both equations this time by a number. In the previous two, depending on which one you eliminated, you could have just multiplied one equation. Now you got to do two, because if you eliminate the x's, you got to get a 20 for the coefficients. 4 times 5, 5 times 4. If you eliminate the y's, you got to get a 10. Negative 5 times 2, 2 times 5, right? So you decide. It does not matter. But most students, though, will navigate to the y's because one's already negative, one's already positive. And so that's what we're going to do. So let's go ahead and eliminate the y. All right, so I'm going to go ahead and rewrite this over. So 4x minus 5y equals 23. 5x plus 2y equals 4. So if I wanted to eliminate the y, remember the least common multiple is 10, so I need this to be a negative 10 in this case. So I got to multiply this by 2. So times 2 times 2, right? What you do one side, you do the other. 2 times 5 is 10, so times 5 times 5. Okay? Remember, the one's already negative, one's already positive, so don't put any negatives here. Now we're going to distribute. 2 times 4x is 8x. 2 times a negative 5y is a negative 10y equal, and then 23 times 2 is 46. The next one, 5 times 5x is 25x. 5 times 2y is a positive 10y. 4 times 5 is 20. Now you see you can add, which remember is step 3. Once you get one of the terms to be opposites, now you add them, and that variable will be eliminated. And so now when I add them, the y's are eliminated. So 8x plus 25x is 33x, right? Equal 46 plus 20 is 66. And now I can get x by itself. And I'm on the right track now. So x divided by x is 1. 1 times x is x. I get x coordinate to be 2. So far my answer, my solution, when I say the answer I mean solution, by the way. My solution is going to be where the ordered pair where x is 2. I'm using the word ordered pair. Ordered pair. So the ordered pair where x is 2, now I got to find the y coordinate. So now I got to solve for y. So to solve for y, you go back to one of those equations. Does not matter which one. I'm going to go to the second one since they're all positive coefficients. So I'm going to use 5x plus 2y equal 4. And in place of x this time, I'm going to substitute 2. So I get 5 times 2 plus 2y equal 4. 5 times 2 is 10, so 10 plus 2y equal 4. Subtract 10 from both sides. I get 2y equals 4 minus 10 is a negative 6. Divide both sides by 2. I get y to be negative 3. And so there's your ordered pair. There's your solution. So the ordered pair that makes this system true at the same time, both equations true at the same time, is this ordered pair where x is 2, y is negative 3. All right. Okay, let's look at number 4. All right, number 4, the last one, number 4. So this number 4, we have the system 16x minus 2y equals 0, and then negative 19x minus 4y equals 51. Okay. All right. So you'll notice that uh, the the x's have pretty large coefficients compared to the y's, and so even though in the x's one's positive, one's negative, most students will navigate to eliminate the y's here because the coefficients are easy to deal with, and also in this case the least common multiple of negative 2 and negative 4 is 4, right? The smallest number that negative 2 and negative 4 go into is a positive 4. And notice this is already a negative 4. You got to make this a positive 4, right? So I'm going to go ahead and rewrite this over. Now, if you wanted to eliminate the axis, the least common multiple of 16 and negative 19 is going to be actually the product of those two. So 16 times 19 is 304. And what's going to happen is this. You would have to multiply this by 19, this by 19, this by 19 if you want to do the axis. Then you have to multiply this by 16, this by 16, this by 16. You see what's going to happen? The numbers get larger. So it's easy to eliminate the y's. Okay? So I'm just rewriting the system over so that way I can go ahead and multiply the equation by number. So I'm just rewriting it over. Okay, now, so I need the coefficients of y's to be 4s. This is already a negative 4. I need this to be a positive 4. So I'm going to multiply this side by a negative 4 and this side by negative 4. And make sure you see why I did negative 4. I'm sorry, not negative 4, excuse me, negative 2. I'm sorry, negative 2. Because negative 2 times a negative 2 is going to be a what? Positive 4. All right, negative 2. So now we're going to distribute. So I'm going to write this over. So negative 2 times 16x is a negative 32x. A negative 2 times a negative 2y is a positive 4y equal, and then 0 times a negative 2 is 0, still 0. The second equation, I didn't multiply anything by because I already had a negative 4. So negative 19x minus 4y equal 51. Now we can add, right? Because I can add now because these are now opposites. So when I add them, negative 32x and then a negative 19x will give us a negative 51x equal, and then 0 plus 51 is 51. And see, when you divide both sides by negative 51, I get the x coordinate to be a 51 divided by negative 51 is a negative 1. So I'm going to write this as a solution. So I found the x coordinate to be negative 1. And all you got to do now is find the y coordinate. So now we got to solve for y. It does not matter which one you use. I'm going to use the first one because that's a 0 here. It may make things a little bit easier. So I'm going to use the first one. It does not matter though, okay? So if you solve for y, you can use either one of those. And I'll do both this time just to show you. So we're going to use, I'm going to go ahead and use the first one, 16x minus 2y equals 0. So in place of x, I'm going to substitute negative 1. So I get 16 times negative 1 minus 2y equals 0, right? 16 times negative 1 is a negative 16 minus 2y equals 0. Adding 16 to both sides, which is what most of you would do. Otherwise, also Some of you may want to bring the y term over since that's a 0, but it does not matter. Most of you would probably do this. But be careful though, because it's not 2y, so negative 2y you get. Negative 2y equals 16. Divide both sides by negative 2. You get y to be negative 8. If you had used the other, I just want to show you, you could have also used the other one. Does not matter. So the other one was negative 19x minus 4y equal 51. So remember, we found x. So in place of x, you're going to substitute negative 1. And we'll make sure, hopefully we'll get y to be negative 8. So I got negative 19 times negative 1 minus 4y equals 51, right? Negative 19 times negative 1 is a positive 19 minus 4y equals 51. Subtracting 19 from both sides. Be careful. This is a negative 4y, not 4y, so make sure you're careful. And then 51 minus 19 gives us 32. Positive 32, right? And divide both sides by negative 4. And I get y to be 32 divided by negative 4 is a negative 8. And that's what we said it was supposed to be. So it doesn't matter which of those two equations you use. You get the same answer. Now I just want to go ahead and check this one again. So again, I could have made a mistake somewhere, right? I could have made a mistake. So let's just check it. Let's just check to make sure it's correct. So let's check negative 1, negative 8 to make sure it's correct. So here's our system. It was 16x minus 2y equals 0. Negative 19x minus 4y equal 51. Okay, so let's check the first one. So in place of x, I'm going to substitute negative 1. In place of y, I'm going to substitute negative 8. So I get 16 times negative 1 minus 2 times negative 8. And I want to see if that's going to equal 0. Well, 16 times negative 1 is a negative 16. A negative 2 times a negative 8 is a positive 16. And when you add them up, you do get 0. All right, now let's do the other one. Negative 19 times x, which is negative 1, minus 4 times y, which is negative 8. And you want to see if that's going to equal 51 this time. 51. Well, negative 19 times negative 1 is a positive 19. A negative 4 times a negative 8 is a positive 32. And when you add them up, you do get 51. So this works out. So negative 1, negative 8 is actually our solution. That ordered pair makes both of those equations true at the same time. Okay? So is that is how you solve a system using elimination / addition. It is not that difficult. Just practice. You just got to practice with these problems and to go through these steps. Okay? So that's the end of this review.